Hi and welcome to the first of what will be a series of videos on how to use and interpret the results of pedigrees. And these are diagrams that are going to be able to allow you, once you learn how to use them, to trace a trait through a family for multiple generations. So I'm going to move me over here. Okay, so the goal for the next several videos here is to be able to use a pedigree to diagram the inheritance of a certain trait or genetic condition through several generations of one family. We've talked a lot about Punnett squares and how we can trace the trait of our interest being passed from the parent generation to the offspring generation. Well, can you go back farther than just the parent generation to trace a trait? Can you go back to the grandparents? Can you go back even farther? Can you, if you have this information, is there a way to very neatly in an organized way be able to trace a trait through a family, through multiple generations? And the answer is yes, you can. And geneticists, anthropologists, other scientists use this tool called a pedigree. So I'm going to teach you how to use that. Okay, so we have, as a part of our learning, this packet called the Lopez Family packet, and this will teach us how to use a pedigree. And for you to get the most out of this, you're going to need to have your packet with you. All right, so this here is the pedigree, and I'm going to kind of teach you some of the rules here on what these symbols mean and who all these shapes are as we move through the questions. All right, so a couple things to note here. A shaded shape, be it a circle or a square, that means that person in that family has blue eyes. So that is a phenotype. Blue eyes is a phenotype, and the shaded shapes have them. The folks that do not have any shade in their shapes, those folks have brown eyes. So their phenotype is brown eyes. Okay? For the sake of tracing this one trait, when we need to write down genotypes and things, we're going to use the letter B for this one. And unless you are told otherwise, in the question or in the pedigree, unless you are told otherwise, all shaded shapes are homozygous recessive. Okay? We need to know that. That's a rule going into pedigrees. Unless you are told otherwise, every shaded shape is an individual with a homozygous recessive genotype for the trait that we're tracing through the family. In this case, we are tracing blue eyes and brown eyes through this family, the Lopez family. So let's begin. Number one, what is this diagram called? It's called a pedigree. And this is something that has been around for a long time. I even used a pedigree in my own anthropology course in college, long time ago. Long time ago, maybe even my freshman year. Yeah, that was the fall of 1997. Just got depressed. Okay, all right, so let's bring it back. Let's channel ourselves, let's focus, let's center, and now we're moving on. Okay, so these have been around for a lot longer than I've been around, and I used one in college to write a pedigree for my family. So these have been around for a while. What do the circles represent? Well, in a pedigree, you're typically going to see circles and squares. At least at our level of understanding, you're going to see circles and squares. And because we're talking about the passage of biological traits from one generation to the next, we're going to talk about males and females. And in this case, what do the circles represent? The circles represent females. Okay, so then that means the squares are all the males. Okay, so up here you have Grandma Lopez and Grandpa Lopez up here. These are the grandparents. Okay, how many children did Mr. and Mrs. Lopez have? Well, this is Mr. and Mrs. Lopez. They're up here. And they are joined together by marriage. So a solid line between two shapes. That is a marriage. And if the marriage brings about children, then you will see a vertical line connected to a horizontal line where other shapes are going to be connected to that line. So if the question is how many children did they have, we'll come down here and follow that line all the way over to the left. So here is a child of the Lopez family, like Mr. and Mrs. Lopez. Here's one of their children because they have this vertical line connected to them. That's not a child of the Lopez family. This one is, so that's 2. See, there's a vertical line connecting, 3 and 4. So they have 4 kids. How many of the Lopez children were male? Okay, well, if we remember that circles are females, then the squares are males. So let's go up to the children of the Lopez family and see how many of them are boys. Nope, that's a girl. That's a girl. 1 boy, 2. So 2 boys. 2 males. Was the oldest Lopez child a boy or a girl? Well, to know the answer to this question, you first have to know how to read a pedigree in this way. When you're talking about birth order, that is something you can get from a pedigree, and you just have to know how to read it. Well, in English and many other languages, we read left to right, and the pedigree is no different. So in a line of children, the one to the far left is the oldest, and you work progressively younger to the right. So in this case, was the oldest Lopez child a boy or a girl? The farthest left over here on the line, on the lineage line, is a circle, and circles are girls. So the oldest Lopez family child is a girl. Okay, now what color are Mrs. Lopez's eyes? Well, Mrs. and Mr., Mrs. Lopez, Mr. Lopez, they're up here. Mrs. Lopez's shape is shaded in. And this tells us down here in the key that shading means that individual's phenotype is blue eyes. Okay, so far so good. So she has blue eyes. She has blue eyes. Okay, next question. How many of the Lopez children have blue eyes? So children of these 2 parents here. This is a child, shaded, so blue eyes. You see a shaded shape here, but he is not a Lopez child. He married a Lopez child, so this does not count. So 1, she has brown eyes. He has blue eyes, so that's 2. He has brown. So 2 of the Lopez children have blue eyes. Okay. Next question. How many generations of the Lopez family are shown on the diagram? Okay, so this is another one of those situations where in order to get this answer right, you have to know how to read the pedigree. So just as I was sharing with you before about we read from left to right, so when you're talking about birth order, left is oldest and you work progressively younger. Well, in English and many other languages, we also read from the top down. So pedigrees have not only a horizontal component, but a vertical component. There are multiple levels of shapes here, starting with the top level. They have kids, so their kids and the kids' spouses are on this level, and if their kids have any kids, they are on this 3rd level, including that one. So how many generations are there in this Lopez family? Well, every level is a generation. So this is OG, the original generation. Okay, here's the 2nd generation and their spouses. And here's the 3rd generation, which would be the grandkids of the Lopezes. Okay, so how many generations are shown? 3. Okay, so far so good. I'm going to move this up slightly because we're starting to run out of room here. I want you to still be able to see the questions. The only thing we're cutting off is where it says Lopez family, but I'm pretty sure you can remember that. Okay, what color eyes, as we're on to question 9, what color eyes does the granddaughter of Mr. and Mrs. Lopez have? Okay, this is Mr. and Mrs. Lopez. Here are their children. So their grandchildren are going to be on this level of the pedigree. Well, that's a boy, 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 girl. So here is their only granddaughter. Okay, now, what color eyes does she have? Well, over here in the key, her shape is not shaded, so the key tells us that those shapes mean brown eyes for that individual. So her phenotype is brown. Brown eyes. A brown-eyed girl, of course. It's a joke for all your parents. You probably don't get it. That's okay. I don't get your jokes. As terrible as they are. Okay, all right, we're moving on. All right, number 10. Write in the genotypes for all of the individuals on this diagram. Okay. This is going to take some time. All right? And this is going to be a situation where you're going to have to rely on how well you can use Punnett squares. And that's okay, because you are all very good at running Punnett squares, because that's what we have spent our last more than a week doing, okay, is running Punnett squares. All right. Now, writing in all the genotypes for about 5 of these folks is very easy. If you remember at the beginning, one of the rules of pedigrees is, unless you're told otherwise, all shaded shapes are homozygous recessive. And remember, we're using the letter B. So here's what we'll do. For all the shaded in shapes, go ahead and write this genotype above or right next to those individuals. Okay? Wherever you can, just write them along there, right in there. Okay, that's easy. Now, from here, it's going to take some figuring. Okay? Because it's not just simple as, oh, well, if the shape is shaded, they must be homozygous recessive. Therefore, all the non-shaded shapes must be homozygous dominant. That's easy. It's not that easy. Because as you know, because you are a Punnett squares genius, homozygous recessive and homozygous dominant are only 2 of the 3 letter combinations for genotypes. There's also a third. Heterozygous. How do you know which ones of these are heterozygous, and how do you know which ones of these are homozygous dominant? You're going to have to use a little bit of this and a little bit of Punnett squares. Now, we start by trying to figure out Mr. Lopez. What is his genotype for eye color? We know his phenotype, but this means up here that in order to have blue eyes, this has to be your genotype. But for brown eyes, you could have one of 2 genotypes, like we were just saying. Either this is going to be your genotype, or you're going to have that. And you can't just guess when there are clues here to be found and clues here to be worked with. The best way to do it, use a Punnett square. So we're going to try to figure out Mr. Lopez first. How do we do this? Well, we already know who he's married to. Now you might be thinking, well, that doesn't matter at all about what he has, because he is not the product of his wife. He is the product of his parents up here somewhere. And you are right. But we have a major clue after Mr. Lopez. We have all of his kids. Remember, they are a clue to what the parents have, right? You can work a Punnett square backwards. You know how this works. So let's do this. Okay, draw a very quick Punnett square over here. It doesn't have to be pretty. It just has to work. We know Mrs. Lopez. Okay, she's going to run this cross. Now, let's think for a second. They have 4 children. Look, one of them comes out homozygous recessive. One of them doesn't. Another one comes out homozygous recessive. The last one doesn't. So, what could you cross this with so that the results come out 50% homozygous recessive and 50% something else? Well, it can't be homozygous dominant Bs. It can't be homozygous dominant Bs, because this would just be heterozygous all the way 100%. And 100% of their kids did not come out heterozygous. So Mr. Lopez can't be homozygous dominant. He also can't be homozygous recessive. How do I know that? His shape isn't shaded in. So, by process of elimination, we can now figure that he has to be heterozygous. And just to be sure, let's run that cross. Okay, so did we cross something with Mrs. Lopez that gives us 50% homozygous recessive and 50% something else? Yes, yes we did. So Mr. Lopez is heterozygous. Okay, we just found Mr. Lopez. Now, if you think about it, we just ran all the possibilities for all of their children. Well, 50% of them came out this way. What did the other 50% have to come out with then? Heterozygous genotypes. Okay, so this child is heterozygous, and so is this one. Science! You got to stay on your toes with me. All right. We found the Lopez's and their children's genotypes. But we're not done, because question number 10 asks us to write in the genotypes for all of the individuals on the pedigree. We've got more figuring to do, but we know now that we can use Punnett squares if we have at least one of the parents and we know what the children are or what they're not. We can work this out using Punnett squares. So the individuals we need to figure out are the spouse and children of both of these Lopez boys. All right, so the process that we use is the same. We have one of the Lopez children, and he is married to, at least what we know, is a female who has brown eyes. So we know she's either this or this. Okay, so we know that. We also know that both of their sons also have brown eyes. So they're going to be either this or this. Okay, so we need to do the same type of thinking that we did up here. Let's draw a quick Punnett square. It does not have to be pretty. It just has to work. We can put him right up here, and we're asking ourselves the same question we asked before. What can we cross with him that down here will give us results we're looking for? And in this case, 0% of these children have blue eyes. So chances are we're looking for what can we cross with this that will give us 0% chance of getting homozygous recessive. Chances are that's what we're looking for. That's our best bet right now. That's our best chance because we don't have any blood samples from her. We don't have blood samples from them. All we know is the phenotype that we see. She has brown eyes and both of their sons have brown eyes. That's all we know. But we're trying to figure out the genes here. So we go on the clues that we have. So what can we cross with him that will give us 0 of these, 0% homozygous recessive? Well, if that's going to work, the only way to give us 0 homozygous recessives in this pane of windows here is going to have to be if she is homozygous dominant. Because that means, as you run the cross, there's a 0% chance of coming out homozygous recessive. So this means that she is homozygous dominant. And that also means, look at the results here, for their children, we just crossed the parents. Now we have the results of what all their kids could be. So guess what he is? He's heterozygous. And so is he. Because their parents have a 100% chance of getting heterozygous children. It's going to happen every time. Okay? Now, we're down to the last Lopez child, spouse, and their children over here on the far right. It's the same process. We know one of the parents' genes, and we know the phenotype of his wife and their 2 children. We know that she and their kids have brown eyes. Okay? We also know that he has brown eyes. So no one in this family is going to have homozygous recessive genes. No one is. So what are the chances then? Let's draw a quick Punnett Square. Okay? Again, doesn't have to be pretty. It just has to work. He, we already know, so let's put him on the Punnett Square. Now we're trying to find her and their kids. What can we cross with him so that we don't get any homozygous recessive results? She is going to have to be homozygous dominant. If she was heterozygous, that would make this a lowercase b, and then over here in this box, we would have a 25% chance of the offspring coming out with homozygous recessive Bs. But look, no one is shaded. No one has blue eyes. So our best bet here is that she is homozygous dominant. That's hers. And if you cross the two parents, here's what you come out with. There's a 50% chance, a 2 out of 4% chance, 2 out of 4, which is 50%. A 2 out of 4 or a 50% chance that their kids will come out with homozygous dominant genes. And there's a 50% chance that their kids, that an offspring could come out with heterozygous genes. So guess what? We don't know which one of these is what. Could they both be homozygous dominant? Yeah, they could. It's possible. Could they both be heterozygous? Yeah, they could. It's possible. It is. But chances are, since there's two kids, and there's a 50 and a 50, chances are one of them is one of these, and the other is the other. Okay? So you get to pick. One of them is probably this, the other one's probably that. But does it really matter? No, it doesn't, because we have no more information on these two. It's okay that we're kind of guessing. We just can't say that, oh, I think this child is homozygous recessive. They're not, because they're not shaded. We know that much. So we've done our best work on these children. And that's all we know about the children, because they're probably not old enough to have kids of their own yet. So if we wanted to know for sure, these children have to grow up and have kids of their own, and then we could narrow it down, like, oh, they really were homozygous dominant, or, oh, wait, they really were heterozygous. Without a blood test, this is all you can really do. Okay, so now we have found all of the genotypes for all of the individuals in the Lopez family. Okay, homozygous recessive, heterozygous. And then we go through the second generation, homozygous recessive, same here, heterozygous, homozygous recessive, homozygous dominant, heterozygous, and homozygous dominant. Then we go to the grandchildren. Clearly homozygous recessive, because he is shaded in. Then it's heterozygous, heterozygous, and then chances are one of them is heterozygous and the other is homozygous dominant. It's not exactly clear which one, but this is good enough because this is all the information we have about these grandkids, so this is fine. Now, number 11 is teaching you another rule about how to use Punnett Square, or how to use pedigrees. Add a cross line to any of the individuals that are heterozygous. Okay, let's go back up here. This is one of those rules in dealing with the shapes that are in the pedigree. Remember how we first started out by saying that all the shaded shapes, unless you are told otherwise, are homozygous recessive. Well, so that's what you do in a pedigree. When someone is homozygous recessive, you shade in their shape. That's just another signal to let the reader know that they're homozygous recessive. But there should be a way to tell the difference between heterozygous and homozygous dominant. And there is. In homozygous dominant shapes, like this one, there is no shading or nothing inside the shape. Nothing at all. Homozygous dominants have nothing inside their shapes. But heterozygous shapes do have a marking inside their shapes, and it is a slash that cuts through half of the shape, like this. Okay. Now, I have seen some pedigrees where not only do they put a slash in, but they color in half of the shape. Either way, for me, is fine. There doesn't seem to be one hard and fast rule about shape or about a slash versus a half shade. So do whatever you would like to do. Just be consistent. Don't change it up in a pedigree. Don't like slash some heterozygous and half shade other heterozygous. Pick one and stick with it. Okay? You can even do that with circles because she is heterozygous. Okay? She gets a slash. Okay? I like slashes. That's fine. You do what you like. Okay? So there's a slash. Here's a slash. Everywhere a slash slash. Old MacDonald had a family. P-E-D-G-I-G-R-E, pedigree. Okay, all right. So all of my heterozygous shapes now have a slash through them. And my homozygous dominants that are supposed to get no shading have been left alone. There's no shading in those shapes. Okay, great. We have now completed our first pedigree. We have used all available information to figure out the genotypes of every individual. We've used Punnett squares when we had to discover those genotypes. We've used phenotype information to help us out along the way. And we have properly shaded or marked every shape. And we've recorded, I might not have said this, in the summary I might not have said this, we recorded all of the genotypes. You can't just figure the genotype without then writing it down next to the individuals. So you got to make sure you fill out the pedigree well. Okay. There are other opportunities for you to do pedigrees in this video series. This is just the first one. You'll see more videos that will be shorter that will help you go through just one pedigree at a time if you're struggling. Okay? This first video is the longest because not only does it run you through your first pedigree, but it also teaches you the basic rules. And we had to work through several Punnett squares, so that does take a little bit of time as well. I will say this is one of your largest pedigrees that you'll work with, but knowing the way to do things, knowing the rules, knowing how to use these and then interpret those results is going to be important, especially when we get into later in the unit. Okay, so here is your first pedigree. More pedigree videos are on the way. Please try these pedigrees and try to work with them first before you seek out the help video. But the help videos will be right after this one. So if you're looking for some help, it's on the way.